Okay, I wanted to make a quick video this afternoon. I have this vehicle come in, and the complaint is the battery's going dead if they don't drive it every day, and especially this last few weeks when we had the real cold weather. They'd have to jump it off in the morning. So we hooked up our digital meter here, and you'll see we're set on the amp milliamp probe. We have the common ground, and you have to plug it into the amp or milliamp, which you always start with the amp. Oops, because it will actually blow the fuse in my meter if the current draw is too much. And so you disconnect the negative cable. I've got the battery charger hooked up so that it keeps the battery charged, and you put one lead on the negative battery post and the other lead on the negative cable, so that any current that's being drawn from the vehicle is actually going through my meter. And you'll see we're at 395 or 85, between 385 and 390 milliamps. And in general, the allowable draw is 55 milliamps. That's 55 thousandths of an amp. Your radio memory, your computer, all that stuff draws a little bit. But in normal practice, we see about 15 to 20 milliamps on a regular vehicle, maybe 25. You're allowed up to 55. And so the first process is we come over to the fuse box, and in the old days we would pull one fuse at a time until the current draw went away or went down to zero. You watch your meter. But I've got a handy dandy, it's called an amp hound, and it's basically a voltmeter, but it has an audible sound. It'll give me a tone if there's no draw, like a beep, and then if there is a draw, it'll go beep beep too, so I can take my probes and test each. It's hard to do on the, you put one on each side of the fuse, that little metal piece, and if there's no draw, it'll just give me one beep, and if there is a draw, there's two beeps. So it's real fast. I can do the same thing with my voltmeter, but it's just faster because I have an audible tone there. And so I went and did all these fuses, and there was no draw detected. So then the next thing I do is I start pulling these bigger fuses out just to see. I mean, I could test them without taking them out by taking the top off, but it's really hard. So I'm speeding everything up here to keep the video short. But when I take that one out, you'll see my draw went completely. There's 1 milliamp there. So then the next step is to pull a schematic, and this is a power distribution, and it is the right front engine compartment fuse box, and you'll see it is that fuse right there, which hopefully you can see that it is fuse number 15, a 40 amp fuse. So when we trace it down, it actually powers up the driver's side under dash fuse box. There's two fuse boxes under the dash. So then we put that fuse back in, and we go to the under dash fuse box, and the same thing, we check each fuse with my amp hound, and I found that this here fuse right here, number 7, was what was causing the draw. So when I pull that fuse out, then I went to about 20 milliamps. So then the next process is to pull another diagram that shows the driver's side under dash fuse box, and you can see all this stuff that's powered by that one fuse. So basically you have to go, and the next step is either to unplug each one of these individual components one at a time, which is very time consuming. So I pull the see if, what did I do? I pull this is the fuse box connector views, and it shows the different connectors. So basically what you do is you see each connector is labeled. That one is I can't read it, X35. So basically you have an X, I think that's an M, a G, G3. So you pull the schematic, it says A, B, C, D. And so you find out where X is. You unplug X from the fuse box and see if your current draw goes away. If the current draw does not go away, then that tells you that that pin, none of this is applicable. So I did that one at a time, and we got down to G3, which actually goes to the rear computer that controls these four things. And so I did the same thing. You got D and G. I think that's a G, or no, yeah, that's a G. Well, it came down to when I unplugged the D terminal, it went down to the 20 milliamps. So then I had either the D2 or D1. Well, that pin D1 isn't available. It doesn't have this power seat module on this vehicle. There's no wire coming out of there, so it had to be this D2, which is the right hand power sliding door module. So then the next thing I would be is to test that power sliding door to see if it's a sensor or the computer, or does the computer think the door's open or ajar or something like that. So just thought it was interesting, and to see that you'd be interested to see how to track down the current draw that's making your battery go dead. It's actually more involved than that, but that's kind of the Cliff Notes version. Sometimes it is that simple that it only takes a few minutes, but a lot of times finding the connector pinouts and the wiring schematics and then tracing them out to see what all is on that circuit is what takes the time. So I hope you enjoy these videos, and we'll catch you on the next one.